Cool. So what I think in the exam will come up is going to be very familiar to the...
Pull them up on your speakers.
Sorry? Oh, right. So I think will be very familiar to what we had in whatever, in the midterm. So I think stack will come up. Conversion from infix to prefix. Some racket.
How are you, lads?
Well, sorry,
Well, what's the crack?
nothing much. We're just doing some snap revision.
No.
Racket. ASTs will definitely come up.
Oh yeah.
Maybe free and bound. When I say ASTs, I kind of mean like convert.
UN,
How are you, bye?
did you get the...
I got the juice. Bye.
You got this.
What's going on in here?
No comment.
Oh,
Yeah, what's the other one? Oh yeah. After X step, what is the output?
the output's 1.
And recursion. So what I will go through is probably we'll go through a little bit of recursion, a little bit of pre and bound, and I will probably go through the converting from prefix to prefix, and I will leave the rest on for use. So I am recording this, so
Cool.
yeah, I'll just slap it on YouTube after we're finished.
Words, so...
Milan getting that ad revenue.
Actually, no, I don't know how to. I don't know how to add YouTube ads to the video.
Yeah, you have to have 1,000 subscribers and same amount of watch time. Yeah.
Fuck, right, not too bad. Not too
Okay,
bad.
let's get him up to 1,000.
Right.
Yeah, we're getting up to 1,000.
Yeah, some will get the bots out.
Oh,
You better be subscribed to Milan on YouTube.
And,
Right, so
If you
They've
aren't,
been
we're
blocking my
gonna-
payments.
so, you know.
I won't give them my tax information.
don't be
true.
They're blocking my ad revenue because I can't legally sign a form and I need to sign a tax form.
Is this for the YouTube video, Milan?
Well, yeah, I'm just going through like what I'm going through.
This is
What
like
is-
every YouTube video from 2011, man. Just typing it in.
Oh my god, yeah.
Hey guys, right?
Welcome to today's video.
Guys, it might
Oh
be
my God.
I might be 2021, but I still live in 2008.
Big yellow ring around the cursor as it clicks.
Oh yes.
Oh shit!
Bandicam logo.
Oh yes.
Make the text a lot
Holy cow.
bigger.
Holy cow! Wait, Sam, you're raping me. I don't know why.
Wow, that's very rude.
What? Just because you're a
Milan,
He can't rape you. He's not 18 yet.
Yeah.
whoa!
Oh, call us
Don't
back.
don't bring that topic in this conversation, okay?
Okay.
Right. So infix to prefix.
He's recording a video of us watching his video.
No. I'm just going to pause this bit. Boom. Right. Do we know the method, the algorithm?
No.
Yes.
No. Well, who has their mic on? Because I can hear myself.
what?
I can hear myself in someone's mic.
That's me, sorry.
Ah, yeah, not too bad. All right. So, anyways, the first thing, well, okay. So you're given an equation. Let's suppose you're given 5 plus 2 times 6, right? Well, the first thing you do is you add brackets according to order of precedence. So you will be left with this, right? Step 1, reverse the expression. Oh fuck, right. Open bracket plus 5 open bracket. Sorry.
Of course, here again.
Now, and here's my stack. Boom. So we're gonna push the closing bracket, and when we come to a number, we push it on. No. Yeah, we push it on and we pop it off immediately. When wait, actually I did it wrong.
No, we push the
6.
upper end. Doesn't no idea. first.
Operator is the plus, and then operand is the number.
Operator, yeah.
Yeah.
Operator, yeah.
So we pushed the 6 on the stack. I popped it off. Now this multiplication stays on. The 2 goes on stack. 2 goes on the stack, and then it comes off. And we come to the corresponding opening bracket. So what happened was I pushed 0, 0, 0, x 0, 0, x 0, right? So that's what happened. Now, when this happens, I pop this, and I pop this. X, 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 and the multiplication goes there. Now we do the same thing for that one. So plus goes on the stack, so 0. The 5 goes on the stack and popped off. So the 5 goes there, and that was pushed and popped. And the bracket goes on the stack. And now we pop everything into this corresponding thing. So we'll do x, x, x. This goes up, this goes up, this goes off. That goes there. And then you have to manually add the brackets back to it. So what you will get is plus 5 multiplication 6, 2. So I reversed it again. And now you add the brackets back to it. Are we clear with this? Any
Good
questions?
job.
Right? So, as long as you guys just remember this, and you have the order of precedence brackets, and then you flip it, then you're grand. So that's one finished. I need a. Boom! We did infix to prefix finish, right? So free bound and unbound stuff. So in the assignment, cool. Whoop. Okay, so look at this equation. Would you like to tell me if this x is bound or unbound? And if it is bound to which lambda?
Bound. It's bound.
It is bound. And what is it bound to?
The one in that the brackets it's in.
Yeah. And what about this one? Is this x bound to this lambda?
No, it's bound to the D.
Bound to the what?
Bound to the D.
Where is the D? Where is
He's
it?
not.
I knew you were gonna say that.
Correct.
So anyways, this one is not bound to this, but it's bound to this. Yeah, I think that's fairly straightforward, unless we'll go look at the quiz. One more. Okay, cool. Right. Do we know the definition of reentrant? Or reentrant?
No.
Okay. Reentrant is if every variable is bound, it's reentrant. So if it has one unbound or a global variable, it is not reentrant. So look at this. So we take 3 parameters, Q, R, and S. S is bound, Q and R are not used, and we have an outside variable called T. So is it reentrant? Is everything bound?
No.
No. Right.
I'm naming
Right.
this.
Right job. Next one. So I take 3 parameters, A, B, D, and then I have plus CB plus BD, and then you multiply the 2 results together. Is it reentrant?
No,
Why not?
because of the C.
Good. Right, and then the last question that I had in the exam was Q and R, and then I have Q by Q, R by T, and then I add them together.
Not reentrant because of the T.
Grand job. Cool. We got the hang of it. Some stack questions. Would you like me to go some of these stacker questions?
Wait, Milan,
Well,
do you mind
yeah.
going through that again, please?
Going through the reentrant or stack?
The kind of bound and unbound thing.
Oh, okay,
Please.
not too bad, not too bad, right?
Thanks, bro.
So, for instance, in this one, so we declare
Yeah.
the lambda function and we take three
Yeah.
arguments.
Yeah.
Take q or an s. We take the
Yeah.
s argument and we divide it by t plus t, right?
Yeah.
So s is bound to this. However,
S is bound to that, yeah.
s is bound to this because we take it as an argument.
Argument, yeah.
However, t is not declared here, therefore it has
So
to
it's
be a
unbound.
called function or a called variable outside. And
One
therefore,
more question. One more question.
go.
Okay, so like it has Q, R, and S, but if that function only had like S's and there was no R, is it still re-entrant since it doesn't have all the variables in it?
Actually, so basically what you're saying is you're taking three arguments, right? So I put in like 1, 2, and 3 for those, right?
Yeah.
I am not using these two. So as long as the t wasn't there, right? Let's suppose it was s divided by 5, right? As a
Yeah.
we're gonna do fancy stuff, right, Michael? We're gonna do revision. Sorry. Fuck this. Fuck Michael.
Nice try.
Okay, Sam. I knew you were gonna call me out again. Ah, there we go. We got there.
Wait, so we can
I'm
we
just going to-
inspect the element tomorrow?
Just change the questions how you like them.
Yeah, I'm just changing the question. So, right. So this is what something similar you're asking, Hans. Yeah. So if like Q and R was not there, but S was there, the S is bound to this. The Q and R are not used, but
Mm-hmm.
the only argument that we're actually using is S, which is bound. Therefore, it is reentrant in that case.
So it's
We don't have-
basically only one has to
No,
re-enter.
no,
Oh.
there has to be no outside variable such as T or A. Anything other than these three, basically.
Okay.
Are we clear with how to evaluate the steps?
Yeah, the innermost deeply nested one.
Yeah, what I like to do in the exam, just because like we're always speedrunning. Ouch. So I write down the whatever equation, right? Plus 2 multiplication 3 5 divided by 5 close bracket, right? I underline this, then I underline this, then I underline this, then I underline this. So I know that this is the deepest. So that's my first step. That's my second step. The plus 2 and wait. Fuck that up. Fuck that up so badly. Okay. Step 1. Then the division goes before addition. And then you do the big division afterwards. So I'm kind of building a pyramid of seeing what's the deepest function. The only reason I did this was because like we had like 2 minutes per or 30 seconds per question or so. What else is there? Abstract syntax tree. Are we happy about application nodes and how calling a function within a function?
What is that?
Like, let's suppose if I want to have a lambda within a lambda.
Oh, do you mind going through that, please?
Yeah, not to worry. So, you know the question we had earlier in assignment, this one, right? So you have a function here, and you have a function here, right? So what's really happening is that we're applying the tree to this one, but we'll start constructing it from outside. So lambda this argument x, where it's plus, and now here's the funny part. Application node lambda x multiplication x x, but because the tree is applied to this, you're applying the 3 to it, and you're adding this x to it. And let's suppose I put a 4 outside here, right? So I'm applying the 4 to this. Those, the way I constructed it makes somewhat sense. I'm gonna take it as a no.
Yeah.
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 So you see how like the plus is here, this here, and then the 3 there, right? So when I add the plus x and the function, I'm actually applying the 3 within the function when I construct the tree. Because you have a function within it, there is going to be something applied to it. Similarly, if my function was lambda x, y, z, and my function is x, y, z, what really happens is you're applying x to y and z. So when you draw the tree for this, it's x, y, z. Application node. No. X. I could be wrong about this one. I think I am wrong. Does anybody know how to actually construct this? Because I'm certain that you introduce the application node and apply it to x, y, and z, but I don't know how to construct it.
You know, I'm starting to wish we had, one of those quizzes for our final exam. It was 120 questions.
With the check answer button still there.
And then, yeah, and then you inspect them and then you screenshot saying, it gave me a different question.
Milan, I think if you can't do it, no one can. Like.
What else was there? Ah, yes, recursion. We'll do recursion on lab 12 because I remember a lot of people didn't attend lab 12. So, would you be able to make a modules function or a mod?
No.
Yeah. Oh.
Yes, sir.
Okay.
Yeah.
Okay, not to worry. Right, so we'll get a brand new drawing
I'd be able
board.
to do it if I had like Racket in front of me and I could mess around, but not on paper.
So
I'm just scared of forgetting everything the moment I open the paper. That's the worst case scenario.
week 12.
At least only 30%. Well, not only, but like at least not 60% or whatever the other ones were.
If I got like 5% in this exam, I'd still pass the module. I think.
Yeah.
So
Unless
basically,
taking the exam fails the module, I don't know.
So basically what Atif... You see, the thing is, I had the TAs on a Friday. So for between Monday and Thursday, they were like experimenting with those classes because they had no idea how to solve it. And whenever Atif came to my class, he's like, "Oh guys, this is how you do it." He was so confident. And then I hear the story that like he had no clue what he was doing on Thursday.
That man did not know how to teach that subject.
So anyways, basically what he was telling us is that if you subtract this number from this and it's less than this, then you return the remainder. Otherwise, you can keep subtracting it until this number is smaller than this. So his approach was the following. You check if x, so you call your x and y argument, so 5 and 3. If x is less than y, then return x because it has to be a remainder. Otherwise, subtract y from x, pass it as an x argument, and keep 3 the same.
That would not work, no?
That will work because you're calling the function again. You're deducting, right? So 5 is greater than 3. So now you're gonna pass it through mod again, but this will be the x argument and this will be the y argument. And the x argument will be 5 minus 3, which is 2. 2 is less than 3, so it returns 2.
I mean, I see. Yeah. Can't you just, just use a inbuilt remainder function to get mod? No?
Yes, but Conor doesn't want that.
Fuck's sake.
Like, there's a reason why he's teaching us this. He wanted to get us thinking about recursion. Question 4. The sum of the first n natural numbers, basically. So if I put in
That's
1,
already-
I get 1. If I put in 2, I get 1 plus 2. So
Which is
what we can check if it's n is equal to or less than 1, right? So if x is less than or equal to 1, I return 1. Otherwise, I add x to 1 less the function. So this will call itself, keep deducting it, and keep adding the numbers before it. So if I pass 3 as an argument or a parameter, 3 is greater than 1, so you add 3 plus the sum of 2. 2 is still greater than 1, so you now have 2 plus sum of 1. And sum of 1 returns 1, but now this is within like loads of addition brackets, so now you have 2 plus 1 plus 3. Makes sense? Question mark.
Yep.
Any questions?
Could you explain the mod one again?
The mod one, not to worry. Not to worry. Not too bad. So we have defined, we take 2 parameters, right? So this will be like 5 and this will be 2. And what Ajit was saying, if you can subtract the number from it, then do it. Otherwise, if this is too big, then return the remainder. So at first we check if 5 is less than 2. If it is less than 2, that must mean it's a remainder. Otherwise, you're passing. So you know how you see how mod. Oops, that should be
The
8.
same as the real.
So you see
Where
how.
did you get that function?
What did I get? The what function?
The define mod to lambda xy.
You make it yourself. So basically, the instruction said, make a mod function, and if you whatever arguments it passes through, this is what should be the result. So it's gonna take a divider and a divisor. So the number and then what you divide it by. We compare which if the number is greater than the divisor or less than the divisor. If it is less than the divisor, it must mean it's a remainder. Otherwise, so you see how mod2 takes 2 arguments, x and y. So when I call mod2 again, it will take an x and y, with the exception that now x equals minus x, y. So I'm actually subtracting the 2 from the 5. So when this is called, now I'm going to pass 3 and 2 for the function. Now it will compare 3 with 2 again. 3 is greater, so we're going to call the function again, which will pass mod 2. Right, so this is my new x value, this is my new y value, which will become mod 2 of 1 and 2. However, 1 is less than 2, so 1 must be a remainder. So it will return the 1. And that's how the function kind of works. Questions?
Yeah, that was fine. Sound.
Alright. Multiples of 6. So basically multiplication is repeated addition. So if you can make a function that will add 6 n number of times, that's where your recursion can be implemented. So my solution was multiple of 6. So you check if x is less than or equal to 0 or 1. So then you return 6, because 1 times 6 is 1, 6, added to 0. Otherwise, add 6 to the multiple of x minus 1. So I keep deducting it until it equals to 1, and then I add up all the 6's. Does it make sense what just happened? I'm going to consider it as a no. Okay.
I understand it.
Do you? Is everyone else?
Makes sense.
I know it makes sense to you. Do we just keep going, or do you want me to cover a bit more of this?
I'd say a fire ahead there.
All right,
Yeah, keep going.
keep going. Right. So would you like to go on to the next topic?
Oh yeah, what about stuff
Wait.
like, recursive ASTs as well? That might
Recur-
come up.
Recursive ASC. Well, technically speaking, if I were to write the mod or the mod function as an AST.
Yeah.
So you have a function called mod 2, which is, oh fuck, how do you start?
You put your if statement first. Your if
No, I'm just debating whether it should be a mod 2 or a lambda there.
It's
Lambda.
lambda on top.
Okay. So lambda, you take 2 arguments, x and y. Oh yeah, this is how Deep does it. He writes out the name on the side like this. Cool. So you take x and y, and what you're doing is if x, y, this is the true part. So if true, return x. Otherwise, mod 2, or in this case, you can do mod. You can either do mod 2 written, or you can do lambda. So application, yeah, mod 2 minus x, y, y. So if I were to keep going, right? So I was given 2 arguments. Do you want to give me 2 different numbers?
Yeah, 1 and 2.
Okay.
Oh no, sorry, 2 and 1, 2 and 1.
Want to go a bit bigger?
48 and 64.
Okay, we'll go with 4 and 3. Right. So the 4 is passed through x. The 3 is passed for y. Now we say, is 4 less than y? No.
Hey, matey.
Well then, you apply 3 for mod 2. And you apply 4 minus 3 as x. You apply it to this. But this is really this whole function again. So what I could do is x, y, if, and just keep going until we get here. Until this condition is true, and just return x. But this is how you construct a AST recursively. Oh yeah, and don't forget the name. And any questions?
No, all good.
No, that's pretty chill.
What else is there? Would you like me to go?
Displays.
What?
Steven's got the 2 displays set up.
I got my spike cam on. I'm recording all of you right now.
Whoa.
Speaking of
So
recording.
you in chat?
Speaking of recording.
Oh, what the fuck? Wait, you actually have recorded?
Yeah.
No way, he's in chat.
Yo, Pog. Yo,
Uh,
you
that
can
was-
hear that.
that
Wait,
was-
can they hear me when I these nuts you?
Yeah.
Fuck yeah, let's go. I want that recording.
You can clip it afterwards. Would you like me to go through any questions from the midterm? Because I saw,
Hello,
for instance,
man.
I saw Hussein here. Hussein is here. Oh, wait. He's over there. Right.
Max, it's hot. It's hot, man.
Hello.
Max, it's hot. It's hot. No, Max.
Put it on.
Max, no.
Jesus fuck. I need to start closing stuff. My RAM can't handle it.
You guys.
Fuck.
Who gigs around?
Hey,
Can't reach.
did somebody say download more RAM?
Saying it like the Christmas lights.
Good.
Going
Right.
strong.
Hussein.
Yes.
Hello. Right. Would you
Hello.
like me to go through what happened here?
Yes, please. Yeah.
Right. So I don't see the top of it. However, I don't think anybody has the test at hand. But oh, you do.
I have.
I have
I,
So X was 6, Y was I can't remember what, and Z was I don't know what.
What is that?
I'm gonna
Send it in the send.
Yeah. If you could, I would appreciate it. I'm not gonna click on that. Guys, everybody vote for Marty.
Which one's Marty?
The catfish.
What?
I'm promoting you. I'm giving you a shout out.
Oh yeah, I think I'm
Thank you.
voting for Milan.
Whoa, is that propaganda?
Oh, you can't see me. Oh.
Ah, Steven, I love your background.
Yo, Stephen boss, I'll match you there, yeah?
I send a picture.
Thank
I'll
you.
match you there, Stephen. Match you there again.
Fuck yeah. That's it.
Alright, boys, so join in. I'll be the fireplace. Yo, Marty, get out of the fire, man. Marty, you're in the fire.
Oh, fuck. Oh, well, Ross.
Which is...
Marty, how's the head?
It's grand now. It wasn't too bad last night.
Okay, this is going to be
Sigma
Four-
grind set. Let's
poor
go.
quality. So
It's good.
what happens is, where's the mouse? Here's the mouse, right? So X is assigned the variable 1 or value 1. Y is assigned the
Oh
variable
shit.
value 2, and Z
Background was like fucking Mario or some
is
shit.
assigned 3. Now we have a function called add2, which takes the Y argument and adds 2 to it. Now this Y is not the same as this Y.
Why?
Doesn't equal because this is an argument or parameter and this is a variable. So
Okay.
I can pass X through here and it will actually grab the value of X. But this Y and this Y are not the same. Unless you pass Y through it, which is the Y variable.
Oh.
So here what you're saying is you take something and you will add 2 to it. Right? But this something is not Y. Like
It's not Y.
it's not the same thing. Now add
Oh.
Y, here we take a parameter or an argument called Z, and you add Y to it. Now this Y is the same as that Y. Because it's not
Oh,
because
yeah.
it's not bound. Unbound. And for here you add Z. So you have X. So you take a variable or a number which is not that is not the same. And you add YZ in it. So you're actually passing you're passing the z through this z, and you add y to that. So what really happens is if I were to expand that function, add z, whoop, plus, so add y, you pass z through it, and add y, when you pass z through it, you get actually z plus y. So plus z y. Now, the reason this is weird is because you actually pass the z variable for a z parameter. So that's why I was able to write it like this. If he were to pass 3 there, I would have to write 3 plus 3y. But we don't worry about it because he passed the z argument. For the add y, you pass the x argument. Again, so you will have plus x, y. And you add that two together. And that is your big function. Now, in this section, so this is what happened here basically. So when he passed z through add y, z, and z had the value of 3, 2 had the value of y, so that should be 5, for instance. Now, anyways, in this section, it's like a set of instructions. So you go from top to bottom, and if something happens, you apply, and you keep it that the same way. So when you do add z x, you're not changing. I've actually felt when I read this question, I was like, Connor Ryan, it's an nasty question, because he's only asking what are the values of the variables after the function was executed. So the value of the variables only change when you have set exclamation mark. You reset the value of x. So
what a dick.
Yeah. So what really happened is, so when he executed it, so x was still had a value of 1, y had a value of 2, and z had a value of 3. So you added, 1 to that, blah, blah, blah. Now you reset x. Now x, you take the value of x and apply it to add 2. X had a value of 1. It was applied to add 2. So 1 is passed through here, 1 is passed through here. So the new value of x is reset to 3. 2 and 3 stay the same because we didn't do anything. Now, x has the value of 3. So when you pass it for add z and you reset it as new x, add z, where is the mouse? Add z is... you take the value of z, you apply it to add y, which is 2 plus 3, so that's 5. And 5 plus 3 is 8. So the new x is actually 8, 2, and 3. You reset z to y. So now z equals y. So they both equal 2. And x is still 8. Messy. Or is messy? Okay, there is messy. So x is now have a new value after you evaluate messy xz. So x and z, which is 8 and 2, are passed through messy. So 8, 2, z, so 2 is passed through add y, but add y takes z, which is 2 is applied here, which means it's applied here, and takes the value of y, which is 2. So this is 4. The x is passed through there, so add y 8. We go back to here, so you pass 8 here, pass 8 here, you add the value of y to it, which is 2. So this will have a value of 10, this will have a value of 4. 10 plus 4 is 14. So x is now worth 14, and y and z stay the same. Have I lost anyone?
What?
Have I lost you guys? Anybody confused?
Just a bit, yeah.
Just a little bit. Okay.
Can you go again from set x add to x?
Yeah.
Yep.
Please, if you wouldn't mind. Thank you.
How did you get like 3?
Okay.
Yeah, please, if you wouldn't mind. Thank you.
Okay, don't worry. Okay. So what you're saying is you guys understood up to here.
Yeah, just
Or before
I
it?
can understand a bit, but why
Okay.
the X?
Isn't
value?
X meant to be 0 there?
No.
Oh no, sorry, that's the second one.
Okay.
My bad. Sorry.
Okay. If I rewrite this in Java, maybe it makes more sense to you guys. Oh, so what we're saying, set x. X, you know when you define, right? That is like x equals 1 in Java.
Yeah.
Semicolon, right? So this line and these two things are the same, but this one is in Java and the other one is in bracket. Now, set exclamation mark is you say x equals and you make a new value. And what you're saying is x equals add to x. So after you execute this function, you assign it to x. But we know that x has a value of 1. So what really happens here is you pass 1 or add 2. So you go to the add 2 function and you pass 1 through it. 1 plus 2 is 3. So x really equals 3.
Okay, we got this. Yeah. I understand now.
And y and z stayed the same.
Wait, one more time.
Okay, not too bad, not too bad.
It's not you, by the way, it's me.
Yeah, no, don't worry. Don't worry. I'm glad you're asking it. Right. So you agree with me that we define x1, define y2, define z3. We're assigning value to these 3 variables.
Yep.
Now, because bracket doesn't let you redefine something, you have to set exclamation mark, which is just a pain, but like that's how it works. So you reset the value of x and you assign this new value to it. So what really happens is you're saying that x equals after you add 2 x, but x had a value of 1.
Yeah.
So what really happens is you're passing 1 as an argument.
Oh, okay. I got you.
Then you go here, you evaluate what add to 1 is.
Yep.
And you assign it to x, and x equals 3. And now the new value of x is 3, 2 for y, and 3 for z.
Yeah, that's perfect.
And you do that for everything.
Does say for example, for the next one, set x, adds x, are we using 3 or are we using...
You're actually using 3 because now x has a value of 3 and you're passing it there.
Alright, perfect.
Good question, yeah.
Yeah, cheers, boss.
So this is like how like Java, if you were to execute it from top to bottom, whatever gets changed, it also applies to the following onwards. And the tricky bit was if you were to calculate like x and z all the way down here. Now I think it was like 14.33. I could be wrong. Let's suppose x was 14 and 3 here, right? Don't worry about this. Messy xz. This will not reset the value x, y, and z. So it stays the same because this just calculates with x and z, but it doesn't reset. So it stays the same and it stays the same for the last one as well. So 3, 14, 3.
So if it doesn't say like set or define, we just keep the values the same.
Yeah, so whenever there's a function that just calculates something like this one, and this last one, the values stay the same. When it was something like this, right, that changes the value, then you actually update x, y, and z according. According to that.
Trying to trick us then.
Yeah, he did.
So
I didn't notice it. Go on.
You know the first place where it says there's set at exclamation mark for the first time.
Yeah.
If you swapped around x, add 2x and x, would add 2 get the value of x? Then.
Hold on, I think I'm gonna write down what you said. So if I have set
add 2.
We can't do that, and there's only one reason. You're calling a function and the next. You need to have a container, which is the variable x. So x is the container that we're resetting the value of. You cannot do add 2. x, because what are you assigning the new value to? This is a function.
X, you're
No.
adding.
Oh, hold up. This is a function that will calculate something.
Yeah.
Yeah, that will return a number.
Yeah.
You cannot reassign a number. If I did this, and this was the answer is 5. You cannot assign the value of 3 to 5. You can assign 3 to x, or you can assign 5 to y, but you cannot assign 5 to 3 or 3 to 5.
Yeah. Okay, that makes sense.
Yeah, so it will always be the other way around. So the variable here, and whatever. Any other question that you would like me to go through specifically?
There was that thing about week 10 or 11 where it said like any parameter could be passed, where it said like apply second argument to the product of the first and the third. Like that assignment.
Week 11 or 12, you say?
I think it was around maybe 10.
From alpha conversion. Oh.
No, not that.
But before we go ahead, do we know what alpha conversion is?
Yeah.
Do you like do a quick example of alpha conversion?
Alpha conversion, not to worry.
You're just changing the names of the variables essentially.
Yeah. So basically, since this one is confusing. And the reason it is confusing. The reason it's confusing because we have so many x's. We have like x here, we have an x here, and then we have 2 arguments here. I just need to figure out which one is bound to which. We have y here, y here. Is this x bound to this one, or is this x bound to this one? So what Color or the alpha conversion does is it simplifies it with using different characters. So the symbol for alpha is like the Greek A. And so let's look at this function for now. Goes up to here. So here we have this x, and here we have this x. Do you agree that these two are bound? So this
No, that x is bound to that one, and the outer x is bound to the other lambda xy.
Yeah, but you agree like the inside is like those two x's are the same.
Yeah.
So the ones I'm pointing at, right? So I can rewrite this section as or whatever that is. This and this are the same thing. I just swapped the x with an a. Now I could do the same thing for the x here, or I can keep it x for now because it's no longer as confusing. But if I wanted it, could do again lambda swap a with b, so by, and then the plus to this function, and then b here. So this x and this x were changed to the letter b, but it's still the same because you're still taking the parameter, the argument in the b, and pass it through here or here.
So basically, you're like changing the.
Yeah.
Kind of differentiating them, so it's easier to read, is it?
Yeah, basically, like in the video, Conor Ryan said, and I love this one. So guys, if you looked at this, and somebody wrote it like this, they deserve to have problems because they don't know which belongs where. But this is where alpha conversion comes in. You change out the matching ones so it's more readable. Like I know now this is this, but this x, I don't know if it's this x, this x, this x, unless I figure out the brackets. I can't just figure it out by looking at it. And similarly here, the y is bound to that, but this y is that y.
Yeah.
Yeah. So I can
So
rewrite. So if I change this to
B.
Give me a different one. I use B here. C.
P.
C. Sorry. So C is passed through here, and if I make this like P, this becomes P. And then my full equation is like lambda C plus, now I said B for this one, but this X is this X. So since this is B already, I have to use B, C, P.
Okay.
And now I can
Yeah.
clearly tell that this is here. It's also here. The Y, which is meant to be P here, is at the end. Also in here. So that's P now. This C is there. And this A is there. And that is like basically change the variables according to the brackets and the functions.
Can you go through that once more?
Yeah.
I don't mean to be annoying, but
Yeah, no worries.
I'm just a little bit stupid.
Whoa, don't say that.
A big bit stupid.
No. Okay, I hate this shit. It's not working.
Brandy, turn on your camera.
Me?
Yeah.
I have it on.
You have what?
I have my camera on.
Boom, that's how we do it, right? So, Brenny, you agree that this is confusing just because we have so many x's in different functions and they appear all over the place.
No, I agree. I'm confused.
Okay, cool. Right. We'll use colors. So this x is this x.
Yes.
This x is this x and this x.
Why?
Right, well, because here we have...
follow
So here we have...
bracket.
Sorry. If we have a function... So we take an argument, we're going to give it the name x, and we add y to it. But this x is not the same as this x.
Because it's not in the same brackets. Like it's...
Yeah.
Grand.
Yeah. Similarly, I can do the same thing to y. So we'll do y on the... Here. So there's a function for y there. And there is another function that contains y. Oops, I went too far. Up here. Cool.
Yes, okay.
I should have used different color there. Orange. So this y, same as this y. But the yellow one, which is this y, appears here. Here. So now, if I were to change the letters according to colors, I could get the following, right?
Grant.
Yeah. Lambda
X,
A,
Y.
right? So A,
fuck.
A, T, right? So everywhere there's a blue X, I have to change it with an A, and everywhere there's a yellow Y, I have to change it to a T. Bracket plus lambda bracket. Now I can change that X because it's a parameter. H, like capital H. Bracket plus H T. Apply A to it. Lambda. We're gonna give this the letter I. Plus AI. And the yellow Y is T. 2, 3. So these two are the same thing, except I just simplified it or made it more easy,
easier, easy readable.
Yeah. So now you know that this is here and here. It's not these, the ones in the middle, or the
These.
No. Don't finish that sentence. Don't finish that sentence.
Hi, Marty, get out of the stables, boy. Marty, get out of the stables, boy. Get out. Connor.
Oh my god.
We love this guy.
Who, Milan?
I love
Milan.
No.
I like a
Yeah, of course we love Milan and
I
Connor.
like a Marty. You like.
Too bad we won't have Connor next semester, I think.
Every
Which one's
time
Connor?
Marty blows into the camera, he just
Connor
disappears
Ryan.
like a ninja.
No.
Kobe Bryant.
I think even Michael English. No.
What else could there be? I think that's really it.
That's there.
If you want something else, I would probably recommend just watch some of the
Yeah,
videos.
will you do Milan?
I'm all
Will
yours.
you do question 1B on the midterm?
I find my midterm test for that.
Wait, do you mind send a picture of it?
Yeah, of course. And I think the exam, the midterm is already on Solus.
Found it.
I'm gonna send it.
Oh, are you talking about the one when we did the open book or the paper? Question 1B with the the square root of x squared minus y squared all over 2xy.
Yo, Ross sister reveal?
What?
What?
Cool. So
I'm gonna send this on.
Look at Matthews.
Saudi Arabia. Good job.
He's gonna get executed. Get out.
No. He's gonna get some oil.
So somebody said they. So Hussein, did you say you sent it somewhere or it's up here?
Hussein said he's gonna send it.
I'm gonna send it. Just wait.
No worries, no rush. I'm really curious why he's duping everything. Did he upload the same thing a year? He actually did. Some man.
Imagine if we next semester we see flowcharts in this module.
Don't even say that, okay?
I never want to see flowcharts again.
Wait, which one's the flowchart again?
Michael.
Marty, why the fuck you in Saudi Arabia?
Why not?
Why
I
not?
I literally just came back and I see Marty in Saudi Arabia.
Well, that's the power
Why
of
not?
a VPN.
Fucking
Ah.
savage.
Shit, I need to get myself no VPN.
See, this is what happens when you get an A1. You get an A1 in Connor Ryan. This is what happens.
Bernie, are you aware that your OBS is on, but your virtual camera is turned off?
Yeah, I know, because I got no camera.
Oh, okay.
My man just wanted to test on the video.
I just want to see enjoying.
Oh,
I
shut
want
the
to
fuck
feel
up
in.
now.
Like I was feeling lonely.
Okay, okay, understandable. All right. So basically, the question in the midterm was to write this as an AST. So what you do is you write it as a single line, right? So we have the divisor, and it goes there.
And I
And
have a good view on the phone.
and then what you could say, like, square root function of x squared minus y squared, v squared, divided by 2 times x times y. But then you could put a bracket around that. Cool. So this side is kind of dealt with. We have to fix
I
this.
want a very good close-up picture of
Square x minus square y squared
I found it.
divided by
This
2
is-
times. This is so fucking bad, right? Now we get a new page.
That was good, man.
Now what you do is
I want to use one of these. Though.
square root
These what?
Oh fuck!
square x minus square y. Now, so this section is this section divided by 2 times x times y. And then what you do is you change it from infix to prefix. So like the multiplication sign
Wait,
will go here.
Milan, say for example he asks us to the power of 3. What the fuck do you think? No, first of all, do you think he'll ask us that? And second of all, how?
Okay, if you were to ask
And
him,
if irrelevant, don't answer.
okay, if you were to do that right, the reason, like, you know, square and square root are not, I could be wrong, but I don't think they are inbuilt in Racket. You have to code it yourself. But he was
Yeah, you
like,
have to code it yourself.
Square root are inbuilt.
but he was but I think he was saying,
Milan, I have the whole exam PDF in the chat.
oh, right,
Okay.
in the chat. Ah, shit, deadly. Thank you.
You are welcome.
So if you were to do that, he would probably specify if you can assume there's a triple function or cubed function already made, or he will ask you to fucking define cube of lambda x, and it returns x by x by x, and then like there's your function made. But I don't think he will do that. He is a nice man most of the time.
Yes, square root and square built into Racket.
And then you grab this and you build into an AST. So you will start with the most inner bracket. No, you start with the most outer bracket. So it would be actually division, because the division is here, and when you go into infix, the division goes there. So you will start with division, top bottom. On the top we have the square root of the square of the subtraction of the square of x minus the square of y, and then you divide it by multiplication 2 times the multiplication of x by y. And that is your answer to question 1b.
Shukran lakum.
What?
Shukran lakum.
Nail hugum uncached.
Shakran lakum.
عفوا.
Oh, you're speaking Saudi Arabian.
He said thank you. Yeah.
Wait, is thank you assalamu alaikum?
No, it's shukran lakum.
Oh, I thought it was like it's like almost the exact same in Urdu. Never mind.
So any other questions? Any other questions?
Who's the little Pete profile photo?
Yeah, just take a look at the beta reduction and the theta, or I think delta conversion. That thing.
Right, I will have to go soon, but to summarize beta conversion, you basically simplify the equation, like control N. I don't say it right. So if I give you this plus multiplication 2, 3, and 4, right? The beta conversion would become plus 6, 4, because it's the same thing except I multiply that one bracket. And then
so
another
multiplying. Okay.
So beta conversion basically means remove the most inner bracket if you can. If you can,
okay.
Yeah. For instance, right, if I have the x here, right, I can only go as far as 6 plus x. I cannot go any further. But if I have a number there, 4, I can. So that's what he means by if you can. And did you say theta conversion?
Alpha
Well,
conversion?
it's delta technically because, like, according to the notes, beta reduction is where you have the whole lambda thing.
Is
Like,
that
where you apply the lambda, that's the application note or something. According to the notebook I have.
yeah,
Malum lambda calculus.
I just can't remember.
Travelers.jpg.
Oh, it's this symbol. I genuinely can't remember if we ever used it.
No, we didn't do that. We did alpha and beta. Alpha and beta.
Alpha, beta. I think that's it.
No, Sigma was kind of Ryan himself.
Oh,
Banter.
if Hans, you can point out to me, I'll go through it. But I'm currently looking at my notes, and
It's on page 34 of the notebook. The thing he handed out.
Oh, okay. The print books. Connor Ryan, page 34. Oh. Oh, I think I know what you mean. Cool. So basically, I think, Hans, you're referring to this symbol in the book.
Yeah, the beta. The big B.
Whatever this is. Okay. Or it's like this in the book. Right?
Oh no, that's the theta. That's the delta conversion.
Okay, well then
Version.
I do not see it. I'm on page 34 and I only
The
see
end
beta
like
course.
thing, the end like thing, that's delta apparently or something.
On the bottom of page 34.
No, the top. Where it says N
Oh,
with the line of word and 3.
Oh, okay, hold up. Conversion evaluation the full level.
Hey.
Oh, okay. I know what Hans means. Good. Right. So if I have a function called lambda x y, I'm gonna put one more bracket around it, and I said plus x y, and I'm applying to 3 the delta conversion, which is like whatever that symbol is. It puts the 2 for x and the 3 for y, so it actually becomes plus 2, 3, and then the beta conversion makes it equal to just 5. So this symbol or the delta conversion just applies the parameter or the arguments into the equation.
Yeah, good. That's
Cool.
good enough. And another thing would be, no, that's really it, to be honest.
Okay, yeah, like, oh, Karen Kutter. I recommend maybe watching a little bit about that. It would put something in. Anyways, I am going to eat with my housemates.
Are you going to come back or no?
No.
Wait, Milan, whereabouts is this video going? The one you have?
I will end it now and I'll show you now.